My name is Carval Lawrence, and I'll be showing you how to do Nernst equation and spontaneity of redox reactions. These are formulas slash just things I think you should know, which is like the constant, which is n equal number of moles of electrons, and F what F is. Just have formulas like change in G equals negative NE FE cell. You should know these as well. And these down here is just E cell equals 0.0592V divided by number of moles times log K. And you can see its counterpart right here, so it's the same thing, just a different logarithm value, which is ln, and a different value up here. Now what you do with those now, sometimes the question asks you if it's going to be a negative value or if eta is going to be positive. This is what it's here for. This is relationships. So if you calculate eta is positive, then you know K is going to be less than 1. You also know the change in G is going to be negative. And you go on hint on blah blah blah. You also know it's going to favor products. Same thing if you found, let's say, a change in G and it was 0, then you know K is going to equal 1. You know eta is also going to be 0, etc. Our first problem is just calculate equilibrium constant for the following reaction at 25 degrees Celsius. It also gives you your balance equation. For one, you should know K, equilibrium constant equals K. So you need to find a formula that fits that, what you're given. And the one I found was this one, which is E cell equals 0.0257 V divided by N multiplied by ln K. For one, the first thing you want to do here is you want to find an E cell. And to find E cell, you need to make a half equations to find the cathode and the anode, which is done here. And that would be anode would be SNS, gives you SN2 plus 2 electrons. By the way, on the other hand, these 2 electrons, you see what you got here? This is N. So you're basically already given that once you do the half reaction. You already have your N already. You already have another value. So the actual formula for finding E cells now, with that, is simply just the cathode minus the anode. To find the cathode or minus the anode, whatnot, this is normally a formula sheet that's given to you. So you would just basically look for, let's say, this reaction. The SN gives you SN2 plus. You would look for it. The professor would normally give it to you, and you would get this value. You look for it, you get 0.15 volts or whatnot, and you do the same thing for this one here, and then you'll get the value. It's just basically a table that gives you those values, and you basically plug and chug it there. Minus gives you this answer, and then you plug it into the actual equation that you have, which is ln K equals NE divided by 0.05V. You're basically just using this same equation, you just basically swapped it around. And also, yeah, like I mentioned before, in the overreaction, I find N equal 2, just 2 electrons. And then to finish off this calculation, you plug in values. Ln equal K equals 2 times 0.29 volts is what you calculated, multiplied by ln divided by 0.0257V gives you 22.6. And keep in mind that this is not your actual answer, even though you normally would. You'd have to put into this form to find equilibrium constant, which is raise it to E raised to the 20 whatever value you got, and it gives you this answer. This you just need to keep that in mind, because it's a little tricky, and even I forget about it. But just keep in mind, this is not your finale. On to the next one. Next equation. Calculate the standard free energy change for the following reaction at 25 degrees Celsius. So it's almost the same thing as the equation we just did, except now you're looking for the standard free energy change, which is change in G, which is this right here. And because we're looking for this, you look for the equation that has the most similar aspects, and that would be this equation. This is what we're using. And again, to find the E, you want to find the E cell first. So if you do that, you need to do your half equation or half reaction, my fault, and find the anode and cathode. And again, plus 6 electrons. You've already found your N. E cell equals E cathode minus the E anode. Again, You look for this equation here in the table that's given. I should have like had an example, but I don't have an example of it. But your professor will know what I'm talking about. You just look for it. It's gonna give you a value 2.87 V, which was for the calcium here, and you do the same for the AU, which is half equation. You do the same thing, and you get these values. And then basically that is just plug and chug. Cathode minus anode, plug and chug. And then you do the actual equation, put it into your actual equation, which would be this equation. Yeah, mentioned that already. So now to find a G is equal to just -6, which is your N right here. F value 96,000. Remember I told you this was a constant? Yeah, that came back to bite your butt right there. E cell, which is what you calculated right here, put it to the -4.37. Just multiply these. And if you want, you change the kilo. If it depends on the question, but normally they want you to do in kilojoules per mole, so you just convert that to kilojoules. And that would be your answer again. And also the large value, that tells you that, like I said, remember the the relationships I mentioned earlier, because it's a large positive value of change in G, that tells us that the reaction favors reactant at equilibrium. Ernst equation. Now this is one of the Ernst equation. These are like extra formulas you should know, which is E equals E to the degrees, or E0 minus RT divided by NF times ln Q. Q is just the concentrations, by the way. And at 298 K, it's another basically same equation, just with again different values and different ln and logs. So this question is asking you to predict whether the following reaction would proceed spontaneously as written as at 298 K. And again, it gives you the balance reaction, but this time now it gives you the concentration. So that should be an instant red flag to me, at least, that it gives you concentration. So you know now that you need Q. You're giving Q. So you should be looking for one of those formulas that have Q in it. First of all, obviously. And predict whether it be spontaneously means you can go like different ways to answer this. But keep it simple. Do the same thing. You find your half equation, your half reaction, cathode and anode. You calculate your E cell, again, cathode minus anode. You, again, like I mentioned before, you look for this in the table. This should also, I messed up here, but this should be an arrow. That is my fault. It should be an arrow here. And it should also be an arrow here. But I messed up. We're just going to pretend that didn't happen. Which would be, again, so you're looking for a cathode minus anode, which is EF to EFT, minus E, which is the anode. And it gives you that value. That's your E cell. Now, the only difference between this and like the positive equation is that it has a Q in there. But now that we have our E cell, which should be right here, we can try to calculate now, which would be 0.16 volts minus 0.0257 volts divided by 2, and your ln 0.15, 0.68. Notice how it's concentration, by the way. It's product over reactants. So your concentration of CO2 was a product, and FET was a reactant. Actually, no, never mind. These are both technically Actually, no, I was right. Damn, I'm messing up my own self. But point taken. Product of reactants, 0.15. This is CO2. It's a product. Reactant, FET. It's a reactant up here. It's a product of reactant. So you're going to put 0.15 over 0.68. And you just plug that into your Q. That's your Q, which is the value you're going to get when you divide these two and multiply it by ln. So you get these two values. You get 0.14 volts. I have no idea why this showed up so late, which is a simpler version of what I was saying. Because E is negative, the reaction is not spontaneous in the written direction. Hopefully that helped, guys. Good luck with your exam, and my apologies for the minor errors in my presentation. Thank you.